Welcome back. So we just learned that 3 to the 5th power as a fraction is 3 to the 5th power over 1. That makes sense. So the reciprocal then is 1 over 3 to the 5th power. I just flipped it upside down. Well, the negative exponent becomes the denominator in fraction, right? Because we saw back here 3 to the 5th power times 3 to the negative 5th power equals 1. So 3 to the negative 5th power is the reciprocal of 3 to the 5th. So 3 to the negative 5th would be the same as 1 over 3 to the 5th, right? I want to take a minute and look. All right, so I took a second to look at this. We were talking about 3 to the 5th times 3 to the negative 5th equals 1, all right? Also, 3 to the 5th over 1 times 1 over 3 to the 5th is the same number. That would be 3 to the 5th over 3 to the 5th power equals 1. So this one right here, 3 to the negative 5th and 1 over 3 to the 5th must be equal. So I can say that if I have exponent with a negative power, then that will equal 1 over the exponent with positive power. Okay? So x to the negative n is going to equal 1 over x to the nth power. That's what that means. So basically, for any number x with a negative exponent, I can write it as a fraction 1 over x to that positive exponent. Okay, so sometimes I want that, sometimes I don't want that. But basically, for any non-zero number x and for any positive integer n, we can say x to the nth, x to the negative n, as 1 over x to the nth. So I got to fix that. And it took me forever to fix this because my computer runs slow when I'm recording and streaming. So x to the negative nth is written as 1 over x to the nth, depending on how I want it. That's the definition of negative exponents. Okay. So let's take a look at this word problem. James says 7 to the 5th times 7 to the negative 9th equals 7 to the 5th minus 9 equals 7 to the negative 4. Monique says 7 to the 5th times 7 to the negative 9th equals 7 to the 5th over 7 to the 9th, which equals 1 over 7 to the 4th. Jayla says, no, they're both right. Who is correct and why? So is James correct? Is Monique correct? Or is Jayla correct when she says everybody's right? Take a minute to think about it and we'll answer it. I took a minute to think about it, but I was paused, so maybe you didn't have any time. But 7 to the negative 9th can be written as 1 over 7 to the 9th. So this is 7 to the 5th times 7 to the 9th times 1 over 7 to the 9th, which would be 7 to the 5th over 7 to the 9th. And 7 times 7 times 7 times 7 times 7 over 7 times 7 times 7 times 7 times 7 times 7 times 7. I can cancel out 5 of those. I've got 4 left, but they're on the denominator, so that's 1 over 7 to the 4th. When I multiply exponents with the same base, I add the exponent, so 5 plus the negative 9 is like 5 minus 9, which is negative 4, so this is 7 to the negative 4. So Jayla is right. They're both right. All right, we got 30 seconds left, and you should have enough information to solve this. You know how to do exponents raised to a power, exponents raised to a power divided by exponents raised to a power, exponents times exponents, and exponents divided by exponents. So pick digits from 1 to 20. You can use any one you want, but you can only use them each once and solve this. If you can do that, that should replace all of the quizzes for the first 5 lessons. And my hint is, what types of numbers are easy to arrange into products? What type of numbers are easy to multiply?